Baby shark do 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 do, baby shark. Mommy shark do 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 do. Mommy shark do 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 do. Mommy shark do 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 do. Mommy shark. Hello, this is Simon the Scientist, and last session I questioned myself, like dense, star with more mass most likely lives longer than a low mass star, but a low mass star turns into a white dwarf, and a high mass star turns into a black hole. And I figured out the answer that a white dwarf lives longer than a black hole. It's 20-something billion years to 13.8 billion.
That's pretty cool.
Or you could just pretty much say 14 billion.
That's pretty cool, Simon. That's really neat that you came back with those answers and did a bit of research. All right, what are you talking about today?
So we are going to be talking about rocks and things about geology. And minerals, not just rocks. So, welcome. I chose this because, in the past I have, seen very interesting rocks, one of which are, halite, and it's kind of like, quartz, except it's like transparent, which basically means partly invisible. Here's halite. To me, it looks cool. And if you're wondering why there are many more bags, we're going to be testing the scale of hardness, which we have one right here. The other one fell over. So there it is. And up there are the things we're actually going to be testing. We're just testing some of these if they're magnetic. Wait. I forgot.
That's all right. Okay, so Simon, why do you like rocks and collecting and all that good stuff?
I always found rocks interesting because, they're just, really cool to find out what's inside, and some of which, look really cool. There's one called, I'm pretty sure. Yeah, and, this one is shaped like triangles, and it's super light.
Cool. So do you collect rocks when we're out walking, or do you check things out, or how does that work?
I don't really collect rocks while I'm walking because there isn't really that much rocks to find. But stuff out in nature and there's a lot of rocks and you can find different types of rocks.
And some really cool ones too. All right, you did some research and you came up with some interesting facts about rocks and minerals.
So you know how water it's not very dense and stuff?
Mm-hmm.
Even though it's not dense, it can still erode rock, which means slowly melts or breaks down something.
That is so cool.
Unlike acid, like hydrofluoric acid, it melts things pretty quickly. But erode means it breaks over time.
Cool. What else did you find out in your research?
Most mountains and stuff curve up because of pressure in the earth.
That's pretty cool.
And also, over time, pressure can change the type of rocks.
That's right. Do you remember, we talked a little bit about this. Do you remember the 3 types of rocks?
Igneous rock, metamorphic rock.
Yeah, you got it.
And I forget the third one.
The third one was sedimentary rock. Yeah, so that's all in
salimentary.
That's all in the rock cycle, but we're gonna save the rock cycle for another session.
And over here we just have some posters.
Yeah.
About rocks and stuff.
Yeah, that's right. We have a really cool rock kit.
Yeah, we're gonna be going to that later, so don't worry.
All right. So today we're looking at minerals. What's the difference between rocks and minerals?
So minerals are they're like pure, and rocks are mixes of such metals. If you break a rock apart, if you have like a really good microscope or something, you can tell the difference in rocks.
So a mineral is a pure substance.
Yeah, like iron and copper and nickel are minerals.
Yeah. What would be an
Well,
example of a rock?
Basically, they're not pure. They're made out of electrons, neutrons, and protons, which are three things.
So now you're getting down to the.
And then there are quarks. And then there are smaller things I haven't discovered yet.
Well, maybe you'll be the one to discover them. That's pretty cool. You got a joke for us today, Simon? Before we get started?
So this is kind of a story one. So here's how it goes. Hey Rock. Yeah? How are you? I'm just heated. Because an igneous rock is created by like volcanoes and like magma and pressure.
Yep. Good one. You want to do one more joke or save it for after?
Let's save it for after.
Sounds good. Let's get started.
I can't really find any good ones, but I'm gonna tell you 3 ways to find out about minerals. Number 1 is looking with a magnifier to yeah.
Yeah.
And then there is number 2 is the streak test. And we're gonna be using this porcelain slab. Kind of looks like a marble. My bathtubs made out of porcelain.
That's right. They are made out of porcelain.
Can I wipe my bottom on you?
Well, I don't know if you want to do that. You might lose that competition. So why don't we start with the first one? You said you wanted.
Probably get eroded.
Probably.
Okay, and the third one is the hardness of Mohs scale. I'm pretty sure it's pronounced.
Yeah, you're right. So let's look at number 1. First, you wanted to look at some minerals with a magnifier and see what you notice.
Oh, this magnifier does it.
No, that's just a piece of glass. We've got a magnifier beside it, though.
I have a question. What is this part? Does this make it tinier?
It makes it, well, let's find out. Okay, let's grab some of your minerals, and we're going to use the camera to look through your magnifier at the minerals and see what we can spot.
So, which one shall we test out first?
These ones here.
So let's do halite.
Yeah, so first we've got halite.
Can you?
I can hold this. You can take one out of the bag. Look, we can even see Simon through the magnifier.
Okay. So here's a halite.
Okay, do you want to put it on the table?
Dustier than I thought.
Yeah. So what do we notice first without the magnifier?
So like it looks like it has a bunch of cracks, and if you were here to feel it, it is very like dusty and has like debris around it.
Okay.
If you like look up closely, there's a lot of debris.
Yeah, now let's look at it closely here. If I hold this, I can line these up together. Now, Simon, when you're looking closely, what do you notice?
So I notice like nothing much, but I can notice a lot more cracks. Like
Yeah. So you notice more cracks in this one.
yeah.
Anything else?
No, not really.
All right, let's go to the next one. We'll keep this piece of halite out, but we'll put it on the bag here.
So we have marble, which kind of looks like salt.
It looks like salt. Let's see. Yeah, we'll take one out of the bag.
Well, hardened salt. What's an entire desert made of salt?
Okay, put that one on the table.
Does it look salty?
Yeah, it looks like there's bumps on it.
Like a bunch of salt.
Very cool. So how does it feel?
So it feels bumpy. And surprisingly, I thought this was going to have a lot of debris, but it barely has any.
Oh, so nothing's really coming off of it.
No. Other than the halite.
Okay, so let's look at this through the magnifier. See if we notice anything else.
A lot more shadowy.
Yeah. I'm having a hard time getting
And a lot
focus. Oh, there
more
we go.
hairy.
Okay, so check that out. Through the magnifier, you can really see the grains. It looks even more like salt now,
Yeah,
but it's actually,
just rock.
yeah, it's marble. It's not a rock, though.
What did you say?
Oh, yeah, sorry. Marble is a rock, sorry. All right, pretty
If
cool.
it was a mineral, then it would be not look salty.
That's right. Okay, so we'll put that one there. What's the next one that you wanted to check out?
Now we have amethyst, precious rare jewel or crystal. I was having amethyst crystal.
Mm-hmm. Let's check out amethyst.
My sister stole it. Yeah, what is this?
You put it down on the table so we can all see it.
What is this?
Well, it's different pieces of the amethyst. Or maybe this was something else that was beside it before. Now, what do you notice? What do you observe about amethyst?
So on this end it's a lot more purple, but on this end it's kind of like clear like halite.
Yeah, leave it in one spot so we can see. Thank you. And now, what if we look through the magnifier? Are we going to notice anything else? Let's see.
I wonder if we could melt it using like the sun rays through the magnifying glass.
I wonder. Come check out through the magnifier, Simon. Is there anything else you noticed by looking closely?
Get a little sparkle and it just disappeared.
Yeah, that's right. A bit of a
back again.
reflection after it.
So it's a lot more darker on the left side.
Mm-hmm.
I'm pretty sure.
Yeah.
Yeah, it's a lot more darker, and for some reason it's a lot more lighter on the right side.
Cool.
And yeah.
All right, we've got 3 more to check out.
So now we have the weird triangular one.
And what's this called?
Sharp. What is this?
Check it out. Okay, put it on the table so we
They
can
look
all
like
see it.
They look like sparkly tin.
Mm-hmm. Look at that from the side. It's very flat.
I know.
What does it feel like?
It feels like polished stone, I guess you could say.
Okay, let's have a look through the magnifier, see if we notice anything else. Come on this side, Simon. I've noticed something else.
It's what?
Look at, you can see even more layers in the mineral than what you can see with your bare
Wow,
eye.
There's a lot of minerals.
Yeah.
If this is pure, then wouldn't it be in the periodic table?
Oh, well, that's different than we're talking about elements. So there's a little bit of difference there, but we can have that discussion and let people know that too afterwards.
Because I'm like,
Check this out. Very cool. All right, next one. We've got 2 more to check out.
this is satisfying to feel.
It is very satisfying to feel.
Magnetite. Probably going to be magnetic.
Magnetite.
Heavy.
Yeah, so you've already noticed that it's very heavy, which means it's very dense. Okay, what else do you notice about magnetite?
Kind of sparkly. I
Yeah.
guess you could say.
Yeah? Any other observations?
It's magnetite.
Look at it up close here through the magnifier and you can see some more. You can see some grooves in it. It's not smooth, it's kind of rough.
And it's fingery.
All right, let's check out the last one there.
Okay.
The last one you've got is?
Hematite.
Okay.
Oh, very sparkly. Kind of looks like someone covered magnetite with glitter. Very sparkly.
Ooh, cool. Is it as heavy as magnetite?
If you look at it, you can see sparkles on the fingers.
Oh yeah, so the sparkles come off really easily.
Sparkles.
Is it as heavy as magnetite? As dense?
I gotta say, this is denser.
Oh, interesting.
It's heavier.
And let's
One
look at it
extra
through.
pound of sparkles.
Yeah, all those sparkles. What else do you notice? The sparkles really are the determining feature here, a distinguishing feature?
Like, I guess there's not really much difference, except it's a lot bigger.
All right. So let's take each of these 6 minerals, and 1 rock, because we have marble there, and let's use the streak test. So let's start with halite that we started with in the first place, and grab your streak plate.
So this.
No, the streak test will be on the porcelain square. Yeah. So why do we use porcelain?
I feel like this is going to make me shiver a lot, because whenever I use chalk, I shiver. And I feel like it's going to do that.
Maybe.
I'm scared.
Okay, let's do this streak test here. Did it leave any mark?
Oh my god, I'm shivering.
Oh, a little bit.
I am shivering.
So what color mark did it leave? What color mark? On the porcelain. You're looking on the porcelain.
Is this a lot whiter?
Yeah, good. Next one. Let's do marble. So we'll wipe that off a little bit. Let's do marble.
I don't marble.
Okay.
That looks salty. Brown dot, freckle. Okay, freckle boy.
Now, what color is that streak?
Yo, it eroded it. This used to be like spiky.
Yeah. Still white. Still the same color.
Pretty.
Now, what color will the streak of amethyst be?
I gotta say, it kind of is purple.
Okay, let's
The
find
purple
out.
end.
Yeah, use the purple end.
Oh my god, that's loud.
Is it leaving any kind of streak?
No,
Nope.
not even once.
All right, now let's
So-
try mica.
Mica is probably gonna break.
It might.
If you look
So let's
at
be careful and
if
see
you
if
look
it works.
at it like really close, you can kind of see it.
Okay,
Like,
keep
looks
it
like
still for a
cardboard.
moment. Keep it still. Yes, I see that. Oh, you were right. A little piece broke off.
But I'm gonna use a stronger one.
Yeah, use a stronger side. Okay, that's good. Did it leave any kind of streak?
No.
All right, just some little pieces that came off.
Well, the pieces came off of mica.
Yeah. Now let's try magnetite. Whoa.
Oh, that's different.
Yeah.
Wait.
Well, it's a darker mineral, isn't it?
Hi.
Nice. And now let's try the last
I'm
one.
gonna wipe it away so we got a clean surface.
Okay.
Oh man, now I got magnetite on my finger.
Now let's try the last one. What's that called again?
Habitat sparkle.
All right. So wait. Before you do it, this is also a dark rock. What color will the streak be?
Dark.
Okay, let's try it out.
Just imagine it's like bright white. Oh, dusty.
Oh, okay, let's see. I can't see the streak plate.
Dusty.
Try again. Oh, well, that's interesting. What color is that streak?
It's like grayish brown.
Yeah. To me, through the camera, it looks like it's got a bit of red in it.
Yeah, I can see it too. It's red.
Interesting. So this is to show the true color, and sometimes the streaks are a little bit different than what the actual mineral is.
Yeah.
All right, so let's put these to the side. And now we're going to focus on these 4 minerals that are up here, and we're going to do a little bit of a hardness test. So
right
can you
here.
bring out Mo's scale? And can you explain what this means?
Both or one?
Just one, because I want to put it on the camera here. So can you explain what Mo's scale of hardness is?
I have no idea how to calculate it because they never taught me.
So yeah, I guess that's what we're doing here today, right?
How?
So it's a scale where if you can successfully scratch it with any of these items, then that's where you learn to place it on this scale of hardness. So we're starting with talc. Simon, you learned some information about talc. What was it?
I just learned something right now. It's the softest.
That's the softest. So can you scratch it with just using your fingernail? So put it down so we can see. Can you scratch it? Did some come off on your nail?
Debris.
Yeah. Let's see if I can do it with my nail.
Is it longer?
Yes, I can.
Not a noticeable difference on the rock, but you can like see it.
Yep, I got some on me. That's for sure.
Okay, so now should we use the copper coin?
Yeah, let's see.
Did I say copper coin?
Yeah, the copper coin, so like a penny.
Yeah.
Will the penny scratch it
Penny.
too?
Oh, fact about pennies, they're not in Canada's money system anymore.
That's right. So is this scratching?
Scratched it.
Yeah, you bet.
Right?
Look, it looks like you're gonna just make a whole bunch of talcum powder.
No more freckle.
Oh, and look at all that powder that came off.
That cheese touch.
All right, so we definitely know that talc was scratched by both fingernail and copper coin, and we know that it's the softest. Let's try the next mineral that we've got here.
That's all right.
Show me the 3 that you've got,
So,
and I'll tell you the order
So
that
we
we're
have-
gonna do them.
feldspar,
Yeah.
calcite, and quartz.
Okay, so let's do calcite next. So first, you're going to have to see if we can scratch it with a fingernail.
That's weird. What happened? Did someone put a bottom on a barbecue?
Maybe. Okay, so put it down so we can see.
I can't really scratch it because there's not like really a surface to scratch.
Well, just pick a little surface, like there's a side right here. I can't scratch it with my fingernail, can you?
No.
Okay, try copper coin. Is it working? Yeah, right. But you were able to create a scratch with the copper coin, so now we know that it's about a 3.
3 or 4.
Yeah.
Because it's pretty tough.
All right. So let's go to the next one on here, which is feldspar. So first, try scratching it with your nail.
Kind of like a red, just peachy brown color.
Yeah, it's a different, interesting color.
So here we have feldspar.
Yeah, put it down. Okay, can you scratch it with your nail?
No.
Okay, can you scratch it with a penny? Did anything come off?
No.
Okay, so now we're going to have to grab the nail. Oh, don't, no, you have to scratch it, not poke it.
Nothing.
Nothing came off? Yeah, let's see if I can try. Let's see here if I can do both and hold the phone at the same time.
I'll hold it.
Okay, good.
Do you want me to hold the phone?
No, that's okay, I got it. Oh, look at, this is interesting. This part over here I was able to scratch, but not really this part here. So it's like they're different a little bit. I'm gonna try this side. Yep, check that out. You can see a little line that I made.
But there's no debris.
Yeah, very little debris. Now the other thing that we can test it with is a piece of glass.
Let's see, it's still like, it still deserves to test it with glass.
Yeah, so let's see. You have to push kind of hard. Good, that's enough. Got it.
Oh.
Look at, there's dust.
Oh, it just shrieked really loud.
So we know that this
Power.
one, would be where on the hardness test?
7, I guess.
Yeah, they have it as a 6. We could have it, 6 or 7. That's
I feel
good.
like it's in the middle.
Now let's test quartz. This is the last one we're going to test. Quartz.
I'm so
Here we go.
awkward.
So can you scratch it with your nail? Not even close.
No.
Penny?
Oh. Nope.
Piece of glass, or sorry, the nail is next.
Nope.
No. And the piece of glass. little bit, but look at what actually happened. You didn't scratch the quartz.
The quartz scratched it.
The quartz scratched the glass.
This must be the glasses.
You have a little bit of a debris from the glass. We have to be very careful with this. So that means that, look at quartz.
This deserves a 9. This deserves.
Well, look, it's right here on the scale where it's actually sitting at a 7, which is harder than glass.
7.
Pretty cool. That is very cool. So what do you think about that?
If I can't break this, then this is stronger than me.
Yeah, that's right.
Yeah.
Okay.
So like,
Do you have one more joke?
no, not now, but I'm gonna tell you the challenge if you wanted to know. It is like around your neighborhood, like anywhere, if you find like an interesting looking rock that you want to find out about, so find out its properties best as you can, and like tell us what your results were and how you found them out.
Yeah. Some observations, what you noticed about the rock when you're looking closely.
Yeah.
Anything else?
No, not really. Thank you and goodbye.